All right, today we're going to do a quick introduction to this concept of complex numbers. So this now brings in what we were talking about. We couldn't take square root of negative numbers, and then we saw on some of these assignments that we did on the Delta Math that, oh, well, when we did this negative, all of a sudden this I popped up. Okay, so this introduces to us this concept of the imaginary unit I. And what the imaginary unit I is equal to is the square root of -1. Okay, so now this allows us to take square roots of these negative numbers. So with this, what we can say now is, well, if I have the square root of -36, that is actually equal to, well, the square root of 36 is 6, and the square root of the -1 is I. And where that kind of comes from is if I look at the square root of -36, well, breaking up a square root, that's the square root of 36 times -1, okay, which is the same thing as the square root of 36 times the square root of -1. And, well, the square root of 36 is 6, and the square root of -1 is I. Okay, so that's where we can get this piece here. We can also use this when when it's not a perfect square that we are simplifying. Say I have the square root of -8. Okay, well, again, that's the square root of square root of 8 times -1, which is the same thing as the square root of 8 times the square root of -1. Now, 8, we know we can break down into 4 and 2. 4 is a perfect square, so the square root of 8 becomes 2 square root of 2, and the square root of -1 is I. Okay, now we need to be careful when we write these, because 2 square root of 2, I want to make sure it doesn't look like I have the I underneath my square root there. So I want to make sure there's enough separation there that it stays separate from that. Okay, so now we can use this concept of this I equals the square root of -1 when I'm solving quadratics and I end up with that negative underneath there. All right, so let's see how that looks when I'm solving one of those problems. So here is a quadratic equation. X squared plus 2x plus 5 equals 0. Okay, so I'm already in standard form. Now, the first thing on something like this that I should look at is say, what is the best method for me to solve it? Okay, and completing the square or quadratic formula are never one of the first things that I'm going to look at, or one of the first methods that I'm going to default to, because they have the most steps involved and the most places where I could make a mistake. So the first thing that I want to look is, can I do square roots? Well, I can't, because I have that 2x term. I have just that linear, that x piece in there. Next, I want to look and say, okay, can I factor this? All right, well, if I'm going to factor it, I'm going to need two things that multiply to 5, but that I can combine, or in this case, add to equal 2. Well, the only things that multiply to 5 are 1 and 5, and I'm not going to be able to combine those to get 2. So that eliminates that. So now I am down to either completing the square or using the quadratic formula. And since I think a little extra practice on completing the square is good, we're going to go ahead and use that method here. So first thing I need to do is move this c value to the other side. So I have x squared plus 2x equals -5. All right, now I want to take my b, which is 2, half of it, so divide it by 2, and then square it. So 2 divided by 2 is 1, 1 squared, well, that equals 1. So I'll add 1 there, and I'll also add 1 over on this right-hand side. Okay? All right, now I can write my left as a perfect square. So that's going to be x plus 1 times x plus 1, or x plus 1 squared, equals -4. All right, now we know we want to take the square root of both sides. Leaves me with x plus 1 on the left. And now we know we have a -4 no real solutions anymore, but the square root of 4 is 2, and because I have the negative, I get my I. And don't forget your plus minus in front, because we have 2 answers in there. All right, now I still don't have x by itself, so we'll subtract 1. So final answer, we get x equals -1 plus or minus 2i. That's how that negative under the square root can be simplified now using this imaginary unit of I, which is equal to the square root of -1. All right, now a little beyond this with complex numbers or imaginary numbers here is we need to look at some different values of I. So this is kind of changing our approach. We're not looking specifically at quadratic solutions here as much anymore, okay? But I, we just saw, is equal to the square root of -1. All right, then we have I squared, which is I times I, which is then the square root of -1 times the square root of -1. Well, they have the same thing underneath the square root there. That just equals, -1. All right, I cubed, well, that's the same thing as I squared times I. We just saw that I squared is -1. So -1 times I is just -I. And the final one we have is I to the 4th. Well, that's I squared times I squared, which is -1 times -1, which equals 1. So I equals the square root of -1. I squared is -1. I cubed is -I. And I to the 4th is 1. And then these things just keep repeating. So I to the 5th would be square root of -1. I to the 6th, -1. I to the 7th, -I. I to the 8th, 1. 9th, 10th, so on and so forth. It just goes in a circle, okay? So sometimes it helps to actually draw it in a circle depending on what power of I we are talking about there. All right, so that will conclude our introduction to complex numbers here, and we will look more at these topics in class.